Today's lesson, we're going to talk about functions and relation. A relation is just a set of ordered pairs. So here's a set of ordered pairs. We know that an ordered pair, you always do x comma y, where x is over here and y is this axis. So if we want to do this ordered pair 1 comma 5, the x value is 1, 1, 2, 3, 4, 5. The y value is 5 there. And 2, 4 would be 2, 1, 2, 3, 4, and 3, 5 would be 1, 2, 3, 1, 2, 3, 4, 5. So 3, 5. So that is those 3 points are a relation. It's a set of ordered pairs. When you have points or a function, the domain is a set of all the first coordinates. So in this case, you're looking at 1, 2, and 3. So the domain, in this case, would just be 1, 2, 3. Be that set of numbers. Range are all the second coordinates, or the y coordinates. So you're looking at 5, 4, and 5. I don't think it's necessary to list both of those. And list it twice, I should say. So 4, 5 is a set of all the range values. We're going to look at this calculator file, actually, just to help us understand this just a little bit better. So if I move this, you can see I moved that to the point 2, 1, and this is called a mapping. And so the input, which is your domain values, is 2. If I input 2 into this relation, it outputs a 1. That's like your range values. And I can grab more points. Kind of a fun little thing you can do here. So I can move it to there, and that maps from 1 to 4. I can move that to here. You can see that in this case, I'm actually going from 4 also to 1. So 2, 1, and 4, 1. They share the same value. We haven't talked about this, but let's talk about a function. So if we do a function, yes, it is a function. That's kind of fun. Let's see if I add another point here. Let's see what happens. So if I add a point here, now I have the point 2, 1 and the point 2, 2. Let's test to see if this is a function. And you can see that it's not a function because the domain value of 2 has 2 partners. Domain of 2 maps to 1, and 2 also maps to 2. That's a no-no. So it doesn't pass what we call the vertical line test. So this is not a function. Even though this is a relation, it's a set of 4 ordered pairs, it's not a function. So we'll get back to that function idea in just a minute. First, let's kind of, again, talk real specifically about what these things are. So when you do a mapping, the first values there in the mapping is the domain, and the second values are the range. And so, like, if we were to graph the point 1, 5, we graph 1, 5 like we did a second ago. We would also go 1 maps to 5, where 1 is the domain and 5 is the range. We could call this x and y here for the table. So in the table, that would be 1, 5, what that might look like in a table. And we'll graph the point 2, 4. That's here. We're going to map the point 2 maps to 4. And 2, 4 in a table. You can just see the different representations of numbers. And then 3, 5 is here. 3, and I'm going to map to that 5 because it goes from 3 to 5. And then 3, 5. Now the table will still list that as a different point there. So a function is a relation. So let's just look at this definition of a function here. This is the official definition. It's a relation in which each element of the domain corresponds with exactly one or only one element of the range. So if you look at this one, again, these are our domain values, these are our range values. So each element in the domain, 3, 7, and 2, has a unique partner, has only one element in there. 2 goes to 2, 7 goes to 2, 3 goes to 5. I would say yes, this is a function. Because all the domain values have one unique partner. It's okay that the range values have more. Go to this one. Is this a function? Well, according to the definition, every element of the domain corresponds with exactly one element of the range. Here's the problem. This guy has two partners, right? So 3 goes to -2. 3 also maps to 1. So this is not a function. This is not a function. Or is it a function? And if you look at this graphically, you might see something here. You'd see that 2, -4, somewhere down here. 3, -2 is here, and then 3, 1 is here. The problem is that there's you're kind of doing like a vertical line test. I'm just going to draw a vertical line. And so you're kind of like, it's an imaginary line here that you're kind of drawing across to get that. Sorry about that. Okay, there we go. And so when you drag that imaginary line across, if it crosses a function or a point in more than one spot, you can see that here, that vertical line is crossing 3, 1 and 3, -2. So it crosses 2 points at the same time. So that's why this is not a function up here. Vertical line test is something we can check. Again, you don't have to like physically draw a line. I am drawing a line here that's somewhat vertical, but you're kind of taking that vertical line and going over the function. You can see it only crosses at one point at a time when it crosses this function. So this is definitely, yes, a function. I would say yes, this is a function because it passes the vertical line test. If the vertical line at any point crosses in more than one spot, like here, you can see temporarily this crosses in a couple different spots. Right, so it crosses right there and it crosses right there, the same kind of x value there. So this is not a function. So I would say no, this is not a function. It's a relation. This is a relation, but this purple line here, this graph, is not a function because it doesn't pass the vertical line test. There are many points actually where a vertical line would cross in more than one spot. And finally over here, if we take our vertical line, it's perfectly straight, but if we go over the function, you can see it only crosses at one point at a time. So as long as it's only hitting the function at one point at a time, we are okay. We would say yes, this is a function. So that's the vertical line test. So you can look at a function and see it different ways there. Finally, let's get to slope-intercept form. We know that the m is the slope of a function. You're probably familiar with this. And this is the y-intercept. One thing you may not be familiar with is the idea that we might start writing this different. So function notation, instead of saying y equals, we'll start using this notation. F of x equals 2x plus 3. And so with this notation, it's another way of saying y. That's not f times x. It's called f of x. It's a new notation. It means the same thing as y. So now sometimes when you see your table, instead of saying x and y like we always have in the past, we may change this. And we could write x comma or x f of x. Right? So we can have some ordered pairs here. So let's just plug in a couple points to make sure you get the idea here. So if I plug 1 in for x, right? So really, with a function, we'd call that f of 1. That means we're plugging 1 into this function. Everywhere there's an x, I'm going to plug in. And when you plug in, make sure that you plug in with parentheses. So 2 times that plus 3. So in the parentheses, I'm plugging 1. So this would be 2 times 1, 2 plus 3 is 5. So the output is 5. Again, we can do that for another number. We plug in 5. This would be f of 5 equals 2 times whatever x is, in this case 5. So 10 plus 3 is 13. So the output is 13. And we could make a table by plugging in values. The old way we used to do this, we used to say if y equals 2x plus 3, then if x equals 1, y equals blank. And so we'd ask the same kind of question. It's a lot easier to say, well, what is f of 1? F of 1 is 5, right? We're saying plug 1 into the f function. This is the f function, 2x plus 3. And your output is 5, which means your y value, or f of x, is 5. So that's just some new notation we're learning, and I really want you to start using, and I think you'll kind of enjoy it. It's a little easier to use than y equals.